spheres. Our objective is to learn and apply the formulas for the volume and surface area of spheres. Who uses this? Biologists study the eyes of deep-sea predators such as the giant squid to learn about their behavior. We might want to know some vocabulary first. A sphere is the set of all points in space that are a fixed distance from a given point. That point is called the center of the sphere. A hemisphere is simply half of a sphere. And the great circle divides a sphere into two hemispheres. Let's start with learning the volume. The volume of a sphere with radius r is volume equals 4/3 pi r cubed. Well, let's try using it. Find each measurement. Give your answer in terms of pi. That means you're going to have pi in your final result. So volume equals 4/3 pi r cubed, and we know our radius is 9. So we can substitute 9 for r in our formula. So we have 4/3 pi times 9 cubed. So 9 cubed times 4 divided by 3 gives us 972 pi. And then we need our units, so centimeters cubed. Let's try this next one. The diameter of a sphere with volume 972 pi. Well, we know the formula for volume is V equals 4/3 pi r cubed. This time they didn't give us what our radius was. They gave us what our volume was. So we can replace our V with 972 pi. So 972 pi equals 4/3 pi r cubed. We want to solve for r, so we're going to solve an algebraic equation. So we see that pi is on both sides of the equation, so we can simply divide both sides of the equation by pi, not 5, and we'll have 972 equals 4/3 r cubed. Okay, so 4/3 is being multiplied with our r cubed, so we can divide by 4/3, which is the same thing as multiplying by the reciprocal. So we're going to multiply both sides by 3/4. So 972 times 3 divided by 4 is 729, and that's going to equal r cubed. Alright, well, since it's cubed instead of squared, we want the cube root instead of the square root. So we want the cube root of 729. On one of your TI-83, TI-84 calculators, you can do this by hitting the math button, which is found underneath your second and alpha key, and then scrolling down and you'll see a key or a number that looks like this, 3 with a little square root symbol here, and then a parenthesis. So if you click on this and then hit enter, and then type in your 729, and then hit enter again, you'll end up with your result, which in this case is 9. So we want the diameter, not the radius, so we need to double it. And so the end answer is 18 inches. So our diameter of a sphere with volume 972 pi is 18 inches. Alright, well, let's try a hemisphere. The volume of a hemisphere. The first thing we may want to do is we may want to figure out what half of the volume of a sphere is. So we can take half of 4/3. So we want half of 4/3, which is going to leave us with 4/6, which can then be reduced to 2/3. So the volume formula for a hemisphere, and you may want to put this down somewhere, instead of being 4/3, it's going to be 2/3 pi r cubed. And now we can do our problem. Our radius is 4, so we can substitute 4 for r. So we have 2/3 pi times 4 cubed. Now, since we want this in terms of pi, we really don't want a decimal as within our answer. So we're going to have to leave it as a fraction. But we can still simplify this. We can do 4 cubed times 2, which is going to give you 128 over 3, because we're going to have to divide it by 3, and then we can leave our pi. So 4 cubed times 2, and then divide it by 3, keep the divided by 3 in your answer, and then replace your pi up here, and then we have to add our units. So in this case, we're dealing with meters, and since it's volume, meters cubed. Let's try a biology application. Giant squid need large eyes to see their prey in low light. The eyeball of a giant squid is approximately a sphere with a diameter of 25 centimeters, which is bigger than a soccer ball. A human eyeball is approximately a sphere with a diameter of 2.5 centimeters. How many times greater is the volume of a giant squid eyeball as the volume of a human eyeball? Take a moment and pause the video and try utilizing the volume formula that we had just practiced using in the last 3 examples to figure out how many times bigger the giant squid eyeball is than the human eyeball. Okay, well, we know the volume formula is 4/3 pi r cubed. So for the human eyeball, we have volume equals 4/3 pi, and now we want the radius, so we want half of 2.5, which is 1.25. So we have 1.25, and we cube that, and that will give us about 8.18 centimeters cubed. Now for the giant squid eyeball, we have volume equals 4/3 pi. We want the radius, so we want half of our 25, which is 12.5. And we're going to cube that as well. And that will give us about 8,181.23 centimeters cubed. Well, if we look at our two numbers and we compare them, we know that the giant squid eyeball is about 1,000 times greater. Well, that would be volume. Let's try surface area. The formula for the surface area of a sphere with radius r is surface area equals 4 pi r squared. So let's try using that formula. The surface area of a sphere with diameter 10 feet. So that means our radius is 5 feet. So surface area was 4 times pi times our radius, so we can substitute r for 5. So 5 squared. So 5 squared is 25. 25 times 4 is 100 pi feet squared. Let me write that number so you can actually read it a little bit clearer. So 100 pi feet squared. Alright, well, let's try this next one. The volume of a sphere with surface area 144 pi. So it's asking for the volume but giving us what the surface area is. This means we want to find what r is, what our radius is. So surface area, so 144 pi, because that's what our surface area is, equals 4 pi r squared. So we want to solve for r. So 144 pi divided by 4 pi is going to give you 36. So 36 equals r squared. Take the square root of both sides, and our radius is 6. Well, now that we have what our radius is, we can simply plug that into the formula for volume. So volume equals 4/3 pi, and our radius is 6, so substitute 6 in for r cubed. So when we simplify this and we want it in terms of pi, so 6 cubed times 4 divided by 3 is going to give you 288 pi, and then meters cubed. Let's try a problem where they give you the great circle. The surface area of a sphere with a great circle that has an area of 4 pi inches squared. Take a moment and try this one on your own, and then we'll try it together. Just like in our previous example, we want to find out what r is. So, a circle, the area of a circle is pi r squared. So the area of a simple circle is pi r squared. Now, pi r squared is going to equal this 4 pi inches squared. So, equals 4 pi. And then we want to solve for r. So we can divide by pi on both sides. So we're left with r squared equals 4. And then the square root of 4 is 2. So our radius is 2 inches. Since we want the surface area, we can plug our r value in. So surface area equals 4 pi, and then substitute our 2 for our radius, so 2 squared. So 2 squared is 4. 4 times 4 is 16. So we have 16 pi inches squared. Let's try a composite figure. Find the surface area and volume of the composite figure. Give your answer in terms of pi. Take a moment and utilize the formulas you now know to find the volume and surface area of the figure to the right. Let's start with the surface area of our hemisphere. So the surface area of our hemisphere, since we don't need to deal with our great circle, is just simply going to be 1/2 4 pi r squared. So our radius is 7, so we can substitute that in. So 1/2 of 4 is 2, so we need 2 times pi times 7 squared. And that is going to give us 98 pi centimeters squared. Now let's try finding the lateral of our cone, since we do not need the base because that is covered as well. So the lateral of our cone is pi r L. Well, we have pi times our radius, which is 7, times our lateral, which is 25. So pi times 7 times 25 is going to give us 175 pi centimeters squared. So to figure out our entire surface area, we just need to simply add these two together. So we'll change to purple here. So we have 98 pi plus 175 pi is going to give us 273 pi centimeters squared. Let's look at the volume. Before we go too far with our volume, we need to know what the height of our cone is. So we can use Pythagorean theorem to figure out our height. So our h, or our height, is going to equal the square root of 25 squared minus 7 squared. This is just an alternate version of Pythagorean theorem, which is a squared plus b squared equals c squared. Well, since our hypotenuse is 25, we need to subtract and then take the square root of that. This is going to give us 24 centimeters. Now we can use this 24 centimeters to find our volume of our cone, and then we'll find the volume of our hemisphere afterwards. Recall that the volume of a cone is 1/3 pi r squared h. So we can substitute our r and our h values in. So we have 1/3 pi times our radius, which is 7. And we're going to square that, and then we're going to multiply that by the height that we figured out. So that's going to be times 24. And when we do so, we end up with 392 pi centimeters cubed because we're dealing with volume. Alright, well now let's deal with our hemisphere. We talked earlier in this presentation about the fact that the volume of the hemisphere is 2/3 pi r cubed, so then we can simply substitute our pi r cubed, and our result is as follows. If you have any questions, ask your teacher.